My name is Hope Michelsen, and I'm an associate professor in the mechanical engineering department. The research in my group focuses on particle formation during high temperature hydrocarbon chemistry. Most people call that soot. So we study soot formation in flames, soot evolution in flames, and also soot evolution in the atmosphere. Many people refer to that as black carbon. We do field measurements for atmospheric studies and instrument development for black carbon measurements. We also develop diagnostics, laser-based, X-ray-based, and other diagnostics for studying soot in flames during formation and evolution. Let me show you a little bit more about our work. Soot is formed during the incomplete combustion of hydrocarbons. There are many sources of soot, including transportation sources, such as cars and airplanes, power generation, such as coal-fired power plants, and natural sources, like wildfires. Soot has an impact on everyone on this planet. It kills nearly 5 million people annually and has a major impact on climate change. It's the number 2 climate change forcer. It also has an impact on our economy, on agriculture, and we really don't know how it's formed. We need better diagnostics, and that's what my group does. We study the physics and chemistry of soot formation. Soot is formed at high temperatures of about 15 to 1700 Kelvin in highly reactive chemical environments. In order to not perturb the chemistry when we make our measurements, we try to deploy techniques that we call in situ, in which we send either a laser beam or an X-ray beam into the flame in order to probe the particles that are formed. We also perform experiments where we put a probe into the flame and extract the particles from the flame and send them into an aerosol mass spec. Here's a video showing of such an experiment in which the particles are extracted from the flame and sent into the aerosol mass spec. They're vaporized, and then the gas phase species are ionized using the vacuum ultraviolet from the synchrotron at the Advanced Light Source at Lawrence Berkeley National Laboratory. We also make measurements and make instrumentation that's relevant to small particles in the atmosphere. This video shows an experiment that we performed in the Arctic to measure small particles that we think are transported from mid-latitudes to high latitudes. These measurements are extremely difficult because it's very hard to make measurements of the particles that are as small as those that can make it that far in the atmosphere. So welcome to CU, and we hope you join our adventure. Thank you.